Bismillah. Good evening, everybody. Tushar sir.
हाँ sir.
Is it getting clear? Getting my voice well?
हाँ voice तो रहे तो है.
Sure. Then.
हाँ ठीक है वैसे तो.
Okay. ठीक है चलिए. Okay. Good evening, everybody. Once again. Yesterday we have started. Yeah. Good evening. Good evening. Yesterday we have started with the structure of atoms. Am I right? So today we are going to continue with the same chapter, structure of atom. It's a very interesting journey to go through the structure of atom. We know it very well. When we start to study with the chemistry, always we start with the matter, and matter is anything which occupies space and possesses weight and whose presence can be detected with our five senses. And we are interested to know how this matter is made up of which particles this matter is made up of, and how is the structure of all these particles in an atom. That is what we are discussing here in the chapter. So that's why we are interested to know the structure of an atom, because every matter is made up of an atom and molecules. And if we know the structure of an atom, then we would be able to predict the properties of an atom. And that's why we are interested to know the structure of atoms. So scientists from the different parts of the world try to find out the structure of atom. 18th century, Dalton is the scientist. Just have a recap. In 18th century, Dalton is the scientist who put forth Dalton's atomic theory. And according to that theory, matter consists of a tiny particle known as atom. Atoms of the same elements are similar. Atoms of the different elements are dissimilar. Or whenever chemical reaction occurs at atomic level. So this is the theory which has been stated by Dalton in the 18th century. Then onwards, the journey began, and we have to discuss. There are different atomic models which are put forth by different scientists, and the different particles of atomic particles which are discovered by the scientists. And that's what we are discussing here in this chapter, structure of an atom. So while we are going to the structure of an atom, we discussed that. In last lecture, we have discussed the introduction to the chapter. What is the content of this chapter? As well, we have seen there are different types of subatomic particles in an atom. First scientist, Faraday, discovered that matter is electrical in nature. Matter can conduct the electricity. That means there should be something present in matter. There should be some particles present in an atom, because of which matter conduct the electricity. And finally, we got that. The first scientist, J.J. Thomson, who performed the discharge tube experiment, and he found the existence of cathode rays. He studied cathode rays well, and he studied the properties of cathode rays, and finally found cathode rays consist of particles which are negative charge particles, and he named these particles as electrons. We have the mass of electron, we have the charge of electron. The first particle is electron, discovered by J.J. Thomson. Furthermore, Goldstein, Rutherford, or many scientists were working to find out the different particle. As a negatively charged electron is present in an atom, there must be a positively charge present in an atom. So with this logic, they may have started, and finally we got Rutherford is the scientist who performed the experiment of alpha scattering at that time. He found the existence of some particles, and these particles were positively charged, and he named these particles as proton. And that the smallest particle is obtained for the hydrogen gas, not for others. Even Goldstein has performed the discharge tube experiment, and Goldstein also found the smallest particle of gaseous hydrogen. Whenever cathode ray strikes on the gaseous hydrogen, it forms cations, and these cations are positively charged. They move towards the negative charge electrode, that is cathode, under the influence of electric current, and these particles were named as, you can say, protons. So you can believe in any of the theories, but finally we got the protons. So we got protons and electrons. So scientists all together added these two particles in any of the atom. So how many protons and electrons are present, that calculated, counted, and they are added. Their mass is added, and finally it has been told that either that mass is equal to with atom or not. But there was always a deficit, because mass of atom is greater and the total mass of protons and electrons is less than that, which was expected to be equal with that, but not. So there should be a presence of some third particle because of which that mass is lacking, or because of which this mass is not completing. So Chadwick is a scientist who, again studying the interaction of radiations with the matter, found this particle, and this particle is neutral because it is not having any charge, and that's why it was lately discovered, because it was difficult to catch that particle. Generally charged particle को catch करना किसी न किसी तरीके से थोड़ा easy होता है. इस particle को catch करना थोड़ा सा difficult था, लेकिन finally that is, you can say here, neutron. which was name was proposed by Rutherford, but the particle is discovered by Chadwick, and finally we got proton, neutrons, and electrons. As of now, we can say the fundamental particles of an atom are protons, neutrons, and electrons. So protons, neutrons, and electrons are the fundamental particles of an atom. That's what we get here. तो ये हम लोग मिल जाता है और ये हमने उसके अंदर discuss कर दिया, देखे हमने, ठीक है? Now, furthermore, journey also continued, and we know there were more than 30 to 35 different types of subatomic particles are discovered till date. 35 more than different types of particles are discovered till date. तो काफी सारे particles हैं. These are called subatomic particles. जिसके अंदर protons, neutrons, electrons are called fundamental particles. But apart from that, we have mesons, pions, gluons, antineutrino, antiprotons, quark particles, that is Higgs boson particles. These are different particles which are present in an atom. ठीक है? कल के लेक्चर में हमने यहाँ तक हमारा जर्नी डिस्कस किया था. आज हमें वापस उसके अंदर चलना है, कुछ फंडामेंटल डेफिनेशन के साथ आगे चलना है, लेकिन हम लोग कुछ फंडामेंटल डेफिनेशंस विद रुदरफोर्ड्स एटॉमिक मॉडल, ये दोनों के साथ हम उसे पैरेलल डिस्कस करेंगे, बिकॉज़ certainly there are some of the properties which are related with the atom के साथ related है, उसके fundamental properties होते हैं, that is you can say atomic number, then isotopes, isobars, atomic mass, neutron number. These are the properties which are related with an atom. बट हम लोग रुदरफोर्ड एटॉमिक मॉडल के साथ उस प्रॉपर्टी को देखेंगे, पैरेलली थोड़ा चलता है एक्चुअली. रुदरफोर्ड एटॉमिक मॉडल थोड़ा समझेगा तो ये प्रॉपर्टी समझना थोड़ा सा आपको आसान बनता है, इजी बनता है. सो लेट्स अहेड विद टुडे वी हैव टू डिस्कस डिफरेंट एटॉमिक मॉडल. हमारे इस बुक के अंदर हमें 4 मॉडल, देयर आर मेनी मॉडल्स पुट फॉर बाय डिफरेंट साइंटिस्ट. आउट ऑफ दैट 4 मॉडल जो है इस बुक के अंदर, इस चैप्टर के अंदर हमें डिस्कस करने. नंबर 1 दैट इज एटॉमिक मॉडल व्हिच इज पुट फॉर बाय रुदरफोर्ड, J.J. Thomson, and then Bohr's atomic model, और fourth one is quantum mechanics model. ये 4 हम लोग को यहाँ पे डिस्कस करना है. तो पहला मॉडल जो बात करते हैं हम लोग, that is you can say Rutherford's atomic model. ठीक है? Actually J.J. Thomson पहला आना चाहिए, क्योंकि J.J. Thomson के बाद Rutherford अच्छा जाता है. तो चलो कोई बात नहीं, हम लोग पहला J.J. Thomson atomic model लेते हैं, फिर उसके बाद हम Rutherford's atomic model लेते हैं. ठीक है? So we have to discuss different atomic models. So first atomic model which is put by Rutherford. So let's move ahead with the atomic model. Atomic models. So what is the structure of atom? How is the structure of atom? This has been put for the different scientists. So first is atomic model by J.J. Thomson. J.J. Thomson. Okay. मेरा handwriting कोशिश अगर थोड़ा सा difficult है, handwriting बहुत ही बुरा है. J.J. Thomson it's important नहीं है. J.J. Thomson. अब देखिए J.J. Thomson ने जो atomic model हमें समझ रखा है कि this is you can say atomic model. So we J.J. Thomson made analogy of this atomic model with watermelon-like structure. अभी हमारे मार्केट में 2 टाइप के वाटरमेलन आते हैं, एक आता है थोड़ा सा ओवल शेप का और एक आता है स्फेरिकल. तो स्फेरिकल वन का वाटरमेलन कंसीडर कीजिए. So this is the sphere one, और इस sphere के अंदर these are the electrons which are here embedded in this sphere. ये sphere के अंदर यहाँ पे आपको electrons मिलते हैं. This is the atomic model you can say here. So according to J.J. Thomson model, J.J. Thomson's atomic model resembles or can be made analogy or can be compared with watermelon. हमारे घर के अंदर हम लोग वाटरमेलन तो लाते हैं, तो उसने कहा कि हमारे जिस तरीके से वाटरमेलन होता है उसी तरीके से स्ट्रक्चर ऑफ एटम होता है. सो दिस इज द स्फीयर. मैं बोर्ड के ऊपर सिर्फ सर्कुलर ड्रॉ कर पाया हूँ, आप उसे स्फीयर कंसीडर कीजिए. स्फीयर मतलब फुटबॉल जैसा, आप समझते हो. सो दिस इज द स्ट्रक्चर व्हिच इज स्फेरिकल वन. तो J.J. Thomson considered the atom as a sphere one. So this is the sphere one, and electrons are embedded in this sphere. Electrons are embedded like मतलब कैसे होता है कि वाटरमेलन के अंदर जैसे सीड्स एम्बेडेड होते हैं, है ना? जिस तरीके से सीड उसके अंदर होते हैं, उसके बल के अंदर प्रेजेंट होते हैं, उसे एम्बेडेड कहा जाता है, जो उसके अंदर प्रेजेंट होते हैं. तो उसी तरीके से ये जो स्फीयर है एटम का, उसके अंदर इलेक्ट्रॉन्स सीड के जैसे एम्बेडेड है. जिस तरीके से सीड्स वाटरमेलन के अंदर एम्बेडेड होते हैं, फ्रूट्स के अंदर एम्बेडेड होते हैं, उसी तरीके से यहाँ पे इलेक्ट्रॉन्स एम्बेडेड है इन द स्फीयर ऑफ एन एटम. Okay. At the same time, the total positive charge is spread throughout this atom, and the total mass of an atom is due to this total sphere. These were the assumptions made by J.J. Thomson. J.J. Thomson ने क्या बताया कि he said that the structure of atom is a spherical one. Electrons are embedded in the sphere. The total mass of this atom is spread throughout the sphere, or is due to the sphere, total sphere. जितना बड़ा एटम का स्फीयर है उसमें उसका मास डिस्ट्रीब्यूटेड है, उसके कारण ही उसका मास होता है, ऐसा उसने कहा. एंड दिस इज द मॉडल पुट फॉर बाय J.J. Thomson. फर्दरमोर जब रुदरफोर्ड्स एटॉमिक मॉडल आते हैं, बोर्स एटॉमिक मॉडल आते हैं, तो वो ये क्लियर करते हैं कि एटम स्ट्रक्चर ऑफ एटम इज स्फेरिकल, नॉट ऑप्टिकल, बट एट द सेम टाइम total mass of atom is not due to the total sphere, that is the positive sphere. That mass is concentrated at the nucleus, and it is very small part of the atom. It is at the center. That's called the nucleus over here. So mass is concentrated in the nucleus of an atom, at the nucleus of the nucleus of an atom, and not due to the total sphere. Sphere is large, comparatively very large, and the nucleus is comparatively very small. And the total mass of an atom is concentrated at the nucleus, not due to the total sphere. So this is the theory which is put forth by the next atomic models, and that's why they rejected this J.J. Thomson atomic model. क्योंकि एटम का मास टोटल स्फीयर के कारण प्रेजेंट होना और एटम का मास न्यूक्लियस के कारण होना, ये दोनों बहुत अलग चीजें हैं. सो आगे की थ्योरीज ये बताते हैं कि एटम का मास न्यूक्लियस के अंदर प्रेजेंट होता है और न्यूक्लियस के कारण है, और ये थ्योरी बताता है कि एटम का मास टोटल स्फीयर में फैला हुआ है, टोटल स्फीयर के कारण है. That was the contradictory statements then, and that's why J.J. Thomson atomic model has been rejected. J.J. Thomson atomic model रिजेक्ट किया गया. atomic model हमारे सामने आता है जिसे कहते हैं हम लोग that is you can say Rutherford's atomic model. So let's move to Rutherford's atomic model, which is second atomic model. पहला atomic model समझ में आया. Number one assumption क्या है? The structure of atom is spherical. Number two, electrons are embedded as like seeds in watermelon. Number three, total mass of an atom due to total sphere, that is sphere. The positive charge is throughout the sphere, like that. So these were the assumptions, and this atomic model is rejected because of the discoveries of next atomic model. So let's move next atomic model by Rutherford. So we have to discuss Rutherford's atomic model. So second atomic model by Rutherford. Okay, so we have to discuss Rutherford's atomic model. Rutherford scientist, जो आपने already 10th में भी देखा था. Rutherford's atomic model we have already discussed in 10th standard. So this is not new to us, not new to you again. So this is very simple. हम अच्छी तरह जानते हैं कि he has done the experiment. तो इसके अंदर कई सारे headings आते हैं. सबसे पहले heading आता है एक experiment, दूसरा आता है observations, फिर आता है conclusions, और fourth आता है atomic model based on the conclusions, and next आता है that is what are the demerits or disadvantages of this model. तो आप देखिए पहला जो आता है, this is nothing but the experiment. So what is the experiment done by this Rutherford? दूसरा, what are the observations? What the observations he made out of this one? तीसरा, what are the conclusions? What are the conclusions what he has drawn? Conclusions. And next, fourth is you can say atomic model. What the atomic model he has put forth us. And fifth one, what are the demerits or disadvantages? Demerits of this atomic model. These are the points what we discuss here. Pehla, what are the experiment? What is the experiment? Number two, what are the observations? Number three, what are the conclusions from this experiment and observations? What the atomic model he put forth? And last is nothing but the disadvantages or demerits of Rutherford's atomic model. Clear with this? तो पहला डिस्कस करते हैं एक्सपेरिमेंट. Rutherford ने क्या किया था? Rutherford took a radioactive element. He took a radioactive element. This is a radioactive element, and radioactive element which emits the radiations. Radiations हमेशा आते हैं, और इसलिए इसे क्लोज करके रखा जाता है इसके अंदर lead box के अंदर क्लोज करके रखा जाता है. So this is the lead box. So this is the radioactive element which is kept in a lead box. Lead box उसके अंदर रखा है, और here is a small opening. यहाँ पे small opening है through this. So this is the radioactive element which emits the radiations. But lead box के अंदर रखा गया है. Lead absorb all the radiations.
Mass है के?
Isn't it? That's right. Okay. So thank you. This is you can say a lead box. Here, radioactive element is put into the lead box because lead is the material which absorbs the radiations. But there is a small opening to this. All the radiations which are emitted by this radioactive element. These radiations are emitted here. Here is the slit. Here is the slit kept. Slit is a you can say thin, thick type of paper. You can say where cardboard. You can say like this. So whatever the radiations comes here in this direction, that will be stopped here, and only here is a small hole through which the radiations are allowed to target. On the target one, that is here, the gold foil is kept. So here a gold foil is kept, which is very thin. Gold foil is kept over here. This gold foil is surrounded by a material. This is surrounded by a material which is a very sensitive material towards the light, called as zinc sulfide screen. So this is the zinc sulfide screen, which is kept around this gold foil. So because now, what are the instrument here in the experiment? We have this lead box. Here is a radioactive material. It is the slit. which is made up of the cardboard, and here is the zinc sulfide screen, and here is the gold foil. So this is what we can say here. So this is the radioactive element. This is nothing but the alpha ray. Alpha ray, alpha radiations. This is nothing but the slit. This is nothing but the radioactive material, which is kept in the lead box, and this is nothing but the zinc sulfide screen, ZNS. This is zinc sulfide screen, which is very sensitive towards the light. What he has done, he took this radioactive material which emits alpha radiations. These alpha radiations are bombarded on this gold foil. They are bombarded on the gold foil. Gold foil paper, they are bombarded. Now, being this is the thing, many of the alpha radiations goes back and strikes here. यहाँ पे strikes होता है. So that's why it is blackened. This zinc sulfide screen is very sensitive towards the light. Whenever this alpha radiation strikes on this zinc sulfide screen, that blackens here. See, we won't be able to see this alpha radiations. Alpha radiations हमें दिखाई नहीं देंगे. जैसे sunlight हमारे पास आता है, sunlight तो आता है, लेकिन radiations आके नहीं दिखाई देते, है ना? तो उसी तरीके से these alpha radiations हम नहीं देख पाएंगे. But ये यहाँ पे blacken हो चुका है. इसका मतलब ये radiations वहाँ पे strike हो चुका है. Some of the radiations deflects less than 90 degree. यहाँ पे strike होते हैं, इधर भी black हो जाता है. तो कुछ यहाँ पे strike होते हैं, यहाँ पे black हो जाता है. Some of the radiations strike in more than 90 degree. यहाँ पे इधर भी black हो जाता है. Some radiation strike here, यहाँ पे black होता है. See, this is the radiation जा रहा है. ये सीधा जाएगा, जो penetrate करके जाएगा इसको. ये जो radiation है, ये less than 90 degree, ये less than 90 degree है, और ये देखेंगे तो greater than 90 degree, but this is 90 degree. इससे ज़्यादा है. और बहुत ही कम, that is 1 out of 30,000 radiations will exactly come back direction. वो यहाँ पे अगर हम material लगाते हैं zinc sulfide पे, तो उधर black होता है. मतलब exactly 30,000 में से 20 to 30,000 में से एक radiation exactly back direction में आएगा. Imagine कीजिए कि 30,000, 20 to 30,000 radiation straight जा रहे हैं, और उसमें से सिर्फ एक radiation back आ रहा है, एक radiation back आ रहा है. 30,000, 20 to 30,000 में से एक radiation back आ रहा है. It's a very, very minimum number. That comes exactly back direction 360 degree में back आता है, isn't it? So this is what. So this is the experiment. The experiment क्या किया उसने? He took a radioactive element, he kept it in a lead box. Here is the slit. Here is the thin gold foil, 0.04 mm thickness, and this is a zinc sulfide screen which is sensitive towards the light. Then he bombarded alpha radiations from the gold foil, and he studied the scattering of these alpha radiations here, and he found that. What are the observations he made? That many of the alpha radiations penetrate through this gold foil and strikes here behind this gold foil on this zinc sulfide screen, and it is blackened here. सबसे ज़्यादा blackened यहाँ पे होगा, because maximum radiation से यहाँ पे strike होता है. Few radiations suffer the deflection greater than 90 degree, like this and this one. So this is the few radiations which deflected less than 90 degree. Very few radiations, that is, you can say this, which deflects in 90 degree plus, more than 90 degree. And very, very few, that is 1 out of 20,000 or 30,000 radiations comes exactly in the back direction. These are the observations what he made. So experiment and his observations. Now, based on the observations, he put forth drawn some conclusions. Once the observations are done, we have the conclusions. Conclusions क्या होता है? अब सीना here कि अभी ये पेन है, और पेन में से अगर हम लोग ऐसे रेडिएशन जाते तो पेन में से रेडिएशन आर पार नहीं जाएगा, है ना? बिकॉज नहीं जाता है उसमें से. लेकिन ये गोल्ड फॉइल जो थीन गया था, इसमें से रेडिएशन आर पार जाते हैं, यहाँ पे रेडिएशन आर पार जाते हैं. सो जिस कारण से अगर यहाँ पे हमारा जो स्क्रीन है ब्लैकन हो चुका है, मतलब मेनी ऑफ द रेडिएशंस हैज पेनिट्रेटेड दिस गोल्ड फॉइल एंड स्ट्राइक्स ऑन दिस zinc sulfide screen. That means there should be a large empty space in an atom. In an atom. और वो किस तरह से एप्लीकेशन? अगर यही जो जिंक गोल्ड फाइल है, देखिए ये गोल्ड फाइल है, जिसे हम लोग मैक्सिमाइज करते हैं. मैक्सिमाइज जैसे कि हम लोग अगर हमारा ग्रुप में फोटो होता है मोबाइल में या किसी डिजिटल में, और फोटो होता है तो हम लोग जूम आउट करके हमारा फोटो देखते हैं. उसी तरीके से मानो कि दिस इज द गोल्ड फॉइल, और ये गोल्ड फॉइल इज मेड अप ऑफ एटम. एब्सोल्युटली नो डाउट, इट्स मेड अप ऑफ एटम. तो एटम का बना हुआ है. सो दिस इज एटम, यू कैन से दिस इज एटम, ये एटम यहाँ पर खुद दिखाई देता है. और जी देखिए, आज तक मैंने बताया कि किसी भी साइंटिस्ट ने एटम नहीं देखा, बिकॉज़ एटम इज बीइंग वेरी वेरी स्मॉल एंटिटी. किसी भी माइक्रोस्कोप, इलेक्ट्रॉन माइक्रोस्कोप के नीचे हम नहीं देख सकते. देखिए, बट रेडिएशंस हैज पेनिट्रेटेड थ्रू द गोल्ड फॉइल. दैट मींस क्या हुआ होगा, लॉजिकली उसका कुछ पिक्चर हमारे सामने आता है. तो ये गोल्ड फॉइल है जिसके अंदर एटम्स प्रेजेंट है, और हम स्ट्रक्चर ऑफ एटम डिस्कस करें तो अल्फा रेडिएशन जब इनके ऊपर बॉम्बार्ड किए गए तो मैक्सिमम अल्फा रेडिएशंस हैज पेनिट्रेटेड गोल्ड फॉइल एंड स्ट्राइक्स ऑन द बैक साइड. मतलब मैक्सिमम रेडिएशंस, अल्फा रेडिएशंस passes through this gold foil. Many of the radiations passes through this gold foil. तो जा कैसे सकते हैं? So this is alpha radiation which passes through this one. देख सकते हो all these radiations passes through this इसमें से done. So maximum radiations, अभी ये diagram बड़ा करके दिखाया like this one. तो maximum radiation passes through this one. Radiations अगर उसमें से pass हो रहे हैं, that means there must be a large empty space. काफी सारा empty space उसके अंदर होना चाहिए, material के अंदर होना चाहिए, atom के अंदर होना चाहिए. Because of which this radiations passes through this. ये पहला. दूसरा, few of the radiations suffer the deflection. ये जो deflection हो चुका है आप देखिए कि ये radiation मान लो यहाँ पे आ जाता है यहाँ पे और ये इस तरीके से जाएगा. या फिर हो सकता है कि ये radiation यहाँ पे और इधर चला जाता है. So whenever this radiation suffers nearby the electron या फिर nearby the positive charge, that suffers the deflections. Like this कि अभी ये जो यहाँ पे positive charge है nucleus, उसके पास से अगर ये radiation जा रहा है तो उसका deflection होता है क्योंकि alpha radiation उसके ऊपर positive charge है. Alpha is nothing but the helium particles, उसके ऊपर positive charge है. Nucleus के ऊपर भी positive charge होता है. There should be a deflection. Like charges has a repulsion. So this radiation got deflected from here. मानो ऐसा होता है कि ये कोई रेडिएशन ऐसा होता है कि ये रेडिएशंस बहुत ही क्लोज आता है तो इस तरीके से डिफ्लेक्शन देता है इस तरीके से. तो जो हम यहाँ पे भी निकाल सकते हैं लाइक दिस, बहुत ही क्लोज आया तो इस तरीके से, मतलब ये जो रेडिएशन से मैंने लिखा है लाइक दिस. सो got more closer to the nucleus, they deflect here in this way, and the radiation which directly strikes on the nucleus, the radiation which directly strikes on the nucleus come exactly in the back direction. मानो ये रेडिएशन डायरेक्टली न्यूक्लियस पे चला जाता है तो सीधा वापस आ जाता है, has to come back. और वो है कितना 1 out of 20,000 to 30,000 radiations एक exactly back आता है. मतलब देखिए कि many of the radiations passes through the gold foil, that means to the atom. Very few suffers the deflection like this. Very few suffers deflection like this one that is greater than 90 degree, and very few, that is 1 out of 30,000 almost radiations comes exactly in the back direction. That means nucleus is too small. 30,000 radiation जा रहे हैं उसमें से एक back आ रहा है. तो 30,000 जितना space acquire करते हैं और उसमें से एक रेडिएशन जितना स्पेस एक्वायर करते हैं वो कंपेयर करेंगे आप लोग तो एक रेडिएशन का स्पेस बहुत कम होगा. दैट इज द न्यूक्लियस ऑफ एन एटम ओनली एंड बाकी रेस्ट इज द स्फीयर ऑफ एटम. सो इस तरीके से. सो these are the conclusions what he has made. So we can get number 1, that is you can see he performed the experiment. Number 2, he made some observations, and number 3, he made some conclusions based on that. And so these are the observations, and that based on the observations he made some conclusions. तो conclusion क्या था? There must be a large empty space because many of the radiation passes through the gold foil. There must be a large empty space in an atom, in this gold foil. पहला. दूसरा, radiations, alpha radiations which are positively charged suffers the deflection, that is less than 90 or greater than 90 degree, because they may pass through the positive charge. तो atom के अंदर कहीं ना कहीं positive charge होना जरूरी है, because of which this alpha radiation suffers the deflection. So there must be a positive charge present in an atom, because of which they suffer the deflection. Yeah, maybe due to the passes nearby the electron, and that's what we deflected. Or last conclusion, which is very important, that is 1 out of 20 to 30,000 radiations come exactly in the back direction. That means there must be a highly dense area. There must be a highly dense area on which these radiations strike and come exactly in the back direction. So there must be a highly dense area in an atom. Atom के अंदर highly dense area होना जरूरी है. तब जाके वो radiations exactly back direction में आता है. So these are the 3 important conclusions what he made. Number 1, there must be a lot of empty space in an atom because of many of the radiations passes through this gold foil. Number 2, some radiations suffer the deflection less than 90 or greater than 90. That means there must be a positive charge or must be negative charge nearby which this alpha radiation passes and suffers the deflections. Or one radiation exactly out of 20 to 30 radiations comes exactly in that direction. That means there may be a highly dense area present in an atom, because of which that radiation comes exactly in that direction. तो आप देखिए कि इमेजिन करो कि मानो हम लोग ऐसा जंगल में कुछ एडवेंचर कर रहे हैं, जंगल में ट्रैक वगैरह कर रहे हैं, कभी आपने शायद किया होगा, नहीं है, लेकिन जंगल में जाना है तो डर की बात है, डरते तो है लोग, डरेंगे. तो मानो 30,000 लोग जा रहे हैं और उसमें से एक बंदा वापस भाग के आता है, तो उसने कुछ तो बहुत ही भयानक और खतरनाक देखा हुआ उस जंगल के अंदर. 30,000 लोग जा रहे हैं और उसमें से सिर्फ एक बंदा वापस आता है. दैट मीन्स कुछ ना कुछ पाया. तो उसी तरीके से एटम के अंदर एक ही रेडिएशन पीछे आता है, मतलब हाईली डेंस एरिया प्रेजेंट इन एन एटम. These were the conclusions, and based on these conclusions we have that is atomic model. Fourth part is nothing but the atomic model. तो इस conclusions के आधार पर उन्होंने atomic model बताया हमारे सामने. So वो atomic model क्या है? What is the atomic model? So the Rutherford's atomic model put forth is nothing but the number 1. The structure of atom is nothing but the spherical one. Structure of atom is nothing but the spherical one. Atom is spherical one. तो जो थॉमसन, मतलब जे थॉमसन ने जो रखा था वही यहाँ पे आ जाता है. So structure of atom is spherical. Atom consists highly dense area at the center called as a nucleus. So this is the nucleus, around which there are here cells in which electrons revolves around the nucleus. Electron revolves around them. So this is nothing but the nucleus, and these are nothing but the electrons. And nucleus consists of protons and neutrons. This one. This is the structure of atom, which is put forth by Rutherford. Rutherford ने atomic model का रखा कि there must be a highly dense area at the center, which is known as nucleus. And nucleus consists of protons and neutrons. तो जो three particles हम कहते हैं कि atom is made up of three fundamental particles: proton, neutrons, and electrons. So out of this, protons and neutrons, which are present in the nucleus, and that's why they are also called the nucleons. जैसा पुणे में रहने वाले बंदे को पुणेकर कहा जाता है, उसी तरीके से न्यूक्लियस में रहने वाले पार्टिकल को न्यूक्लियॉन्स कह सकते हैं हम लोग. So in that sense, protons and neutrons are the nucleons because they are present in the nucleus. A nucleus is very, very small as compared with the total structure of atom, total sphere of an atom, and it is highly dense area. Whereas electrons revolves around the nucleus as like extraplanetary particles. So electrons revolves around the nucleus. And the total mass of an atom is due to the nucleus, being it's highly dense and total protons and neutrons are present in the nucleus. Total mass of an atom is concentrated at the nucleus. This is the structure of atom which is put forth by Rutherford. We got it. So based on the experiment, observations, and conclusions, he put forth the atomic model. So according to Rutherford's atomic model, the structure of atom is spherical. Atom consists centrally situated, highly dense area known as nucleus. Protons and neutrons are present in the nucleus and they're also known as nucleons. Whereas total mass of atom is concentrated at the nucleus because of protons and neutrons. And electrons, which are negative charged particles, revolves around the nucleus. This is the structure which is put forth by Rutherford. But is Rutherford atomic model के structure के कुछ drawbacks भी आते हैं. So we have drawbacks of this Rutherford atomic model. What are the drawbacks of this Rutherford atomic model? Now see, at the same time, physics में कुछ experiment चल रहे थे और वहां पे physics के अंदर जो कुछ experiment चल रहे थे उसके अंदर कुछ theories सामने आते हैं. क्या theories सामने आते हैं उसके अंदर कि the particles, whichever charged particles revolves in circular orbit, that emits the energy. Whenever any charged particles revolves in a circular motion, that emits the energy. And when it emits the energy must decrease. उसका energy क्या होता है? Decrease होता है. जैसे कि देखो कि हम लोग मानो स्कूल में जाते हैं, कॉलेज में जाते हैं और हम लोग को कभी फिजिकल एक्सरसाइज का हमारा पीरियड होता है, हमें बोला जाता है कि आपको ग्राउंड के चक्कर काटने हैं, बहुत बड़े ग्राउंड के चक्कर काटने हैं. तो नॉर्मली हम टीचर सेंटर में खड़े होते हैं ग्राउंड पे एज लाइक न्यूक्लियस ऑफ एन एटम, और हम लोग बच्चे स्टूडेंट क्या करते हैं, ग्राउंड के चक्कर काटते हैं. तो हमें से कुछ बहुत सारे बच्चे होते हैं, वो जानते हैं कि जितना दूर से भागेंगे उतना एनर्जी जाता है, तो रेडियस कम कर देते हैं, वो थोड़ा अंदर से भागते भागते हम लोग धीरे धीरे अपने अंदर आते हैं. टीचर का वहां से सीटी बजा आवाज आए तो वापस बाहर जाते हैं, नहीं आगे वापस अंदर आते हैं. लेकिन धीरे धीरे हम लोग अपना रेडियस कम करते जाते हैं, क्योंकि रेडियस जितना बढ़ेगा उतना ज्यादा एनर्जी चाहिए, और रेडियस जितना कम होगा उतना एनर्जी कम लगता जाएगा. यहाँ पे फिजिक्स का एक थ्योरी रिवील करता है कि whenever any charged particle revolves in circular orbit, that emits the energy, और whenever it emits the energy, उसका एनर्जी डिक्रीज होता है, और इसका एनर्जी डिक्रीज होगा तो फाइनली इट फॉल्स इनटू द न्यूक्लियस. सो दैट पार्टिकल मस्ट फॉलो अ स्पाइरल पाथ, नॉट द सर्कुलर पाथ. तो आप देखिए ना कि थ्योरी के हिसाब से दिस इज द न्यूक्लियस एंड सपोज दिस इज द इलेक्ट्रॉन. Electron being a charged particle, when this electron revolves in a circular orbit, this electron must decrease its energy. और इस इलेक्ट्रॉन का एनर्जी अगर कम होता जाता है तो रेडियस डिक्रीजेस, तो फॉलोज स्पाइरल पाथ, और स्पाइरल पाथ फॉलो करके फाइनली उसका fall into the nucleus. So this is the spiral path and this is the circular path. So what happens here, जैसे मैंने बताया आपको कि electron being a charged particle, when it revolves around the circular motion, when it revolves around the circular nucleus, its energy decreases, and when its energy decreases, it follows the spiral path and finally falls into the nucleus. Nucleus के अंदर fall होता है. अगर इलेक्ट्रॉन न्यूक्लियस में फॉल होगा, इलेक्ट्रॉन न्यूक्लियस में अगर फॉल होगा, तो स्ट्रक्चर ऑफ एटम doesn't, मतलब never exist, it didn't exist over there, वो exist होता ही नहीं, और स्ट्रक्चर ऑफ एटम exist नहीं होगा तो मैटर भी उस तरीके से exist नहीं होगा. So that was again one of the important disadvantage which has been found, demerit which has been found. Next one, Rutherford could not explain the spectrum of hydrogen atom. Rutherford could not explain the spectrum of hydrogen. Hydrogen का जो spectrum है वो Rutherford explain नहीं कर पाया. That is also one of the important you can say demerit of this Rutherford atomic model. Remember this. And That's why this concept, this Rutherford's atomic model has to be rejected, and we have to not rejected, but we have to consider for better model than this, because many of the explanations, many of the concepts are very clear by this Rutherford. This is the first scientist. This is the scientist who first time put a very conceptual atomic model based on some based experiment and observations and conclusions in a logical way. But there are some certain demerits and disadvantages of this atomic model. So we have to find out, we have to search for next atomic model. So we have to discuss next atomic model by different scientists. That's what Bohr's atomic model. But Bohr's atomic model को जाने से पहले कुछ fundamental definition आते हैं, कुछ basic definition जो हमें discuss करनी होती है. ठीक है? So हम लोग discuss कर रहे हैं structure of atom, जिसके अंदर के we have to discuss the atomic models put forth by different scientists. So we have discussed two atomic models. Number one, atomic model put forth by J.J. Thomson atomic model, which is rejected. Second atomic model called as Rutherford's atomic model. Experiment, observations, conclusions, atomic model and its demerits. So these are the points related with this Rutherford's atomic model. Now, based on that, we have to study some fundamental concept related with an atom. Atom के साथ related which fundamental concept हमें discuss करना है. वो discuss करते हैं. उसके बाद third atomic model के move करेंगे. That's called as you can say Bohr's atomic model. ठीक है? But Bohr's atomic model अगर आपको समझना है तो Rutherford's atomic model पहले clearly understood होना चाहिए. So what I will suggest you, just go through the this Rutherford's atomic model, go through your book, read it well, try to understand. If in doubt and difficulty, let me know. Accordingly, we can discuss. Then you would be able to understood well Bohr's atomic model and then quantum atomic model. So let's move with next part, next concept, called as you can say here. Fundamental definitions or fundamental concepts related with an atom. So some fundamental concepts related with an atom. Fundamental concepts. So those fundamental concepts के अंदर आता है. Number one, there is you can say यहाँ पे लिखूँ. Number one, you can say atomic number that is denoted by Z. दूसरा, you can say atomic mass number denoted by A. तीसरा, neutron number that is capital N. ये तीन concept हमें discuss करने हैं. These are the three concepts that we have to discuss. So number one is atomic number of an atom. Number two, you can say atomic mass number, that is atomic weight. And तीसरा, neutron number of an atom. Now see, Mosley नाम का एक scientist एक study कर रहा था, experiment कर रहा था. तो क्या experiment कर रहा था वो? उसने क्या किया कि cathode rays, these are cathode rays. Cathode rays are strike on a metal plate. So ये metal plate के ऊपर cathode rays उसने strike किया. So this is the metal plate और इस metal plate के ऊपर cathode rays strike किया. जैसे metal plate के ऊपर cathode rays strike होते हैं, वहां से नए radiations release होते हैं. अगर मैं ऐसा करता हूँ, या ऐसा निकालता हूँ, so यहाँ से new radiations आएंगे like this. So cathode rays are allowed to strike on the metal plate. और metal plate के ऊपर strike होते हैं तो metal plate से नए radiations emit होते हैं. And these radiations are called as, you can say, X-rays. These new radiations are called as X-rays. So whenever cathode rays allowed to strike on the metal plates emit some new radiations, and these new radiations are called as X-rays. Mosley is the scientist who studied the square root of this frequency of this X-rays. So square root of frequency is this, given by mu. So square root of frequencies of X-rays is directly proportional to specific integer potential Z. Specific integer potential Z. मतलब इसका मतलब क्या है देखना कि ये जो रेडिएशंस इमिट हो रहा है, इस रेडिएशंस का फ्रीक्वेंसी उन्होंने स्टडी किया और उसका स्क्वायर रूट जो है दैट इज डायरेक्टली प्रोपोर्शनल टू स्पेसिफिक इंटीजर. एक ऐसा नंबर मिलता है हमको जो हर मेटल के लिए, हर एलिमेंट के लिए अपना है, अलग. मतलब यहाँ पे अगर हम लोग आयरन मेटल प्लेट रखते हैं तो आयरन मेटल प्लेट के लिए Z का वैल्यू अलग आता है, लेकिन फिक्स आता है, उतना ही आता है. अगर यहाँ पे हम लोग एल्यूमिनियम प्लेट रखते हैं तो एल्यूमिनियम प्लेट के लिए ये वैल्यू अलग आता है. अगर यहाँ पे हम लोग कॉपर का प्लेट लगते हैं तो कॉपर प्लेट का Z का वैल्यू अलग आता है. हर मेटल का Z वैल्यू एक स्पेसिफिक आता है और डिफरेंट आता है. सेम मेटल का, हाँ, यहाँ पे आयरन के आप कितने भी प्लेट रख दो, यहाँ पे Z का वैल्यू नहीं बदलेगा. आयरन के अलग अलग प्लेट रख दो, Z का वैल्यू नहीं बदलेगा. कॉपर के अलग अलग प्लेट रखो, Z का वैल्यू नहीं बदलेगा. बस जिंक, कॉपर, एल्यूमिनियम ऐसे मेटल बदलते रहो, Z बदलता रहेगा. मतलब we got different value of Z for different element. And that is been done by a Mosley scientist. Mosley scientist ने ये कर दिया. He found that whenever cathode ray strikes on the metal plate emits X-rays, and he studied the square root frequency of this X-rays, which is directly proportional to specific integer, and he named this specific integer as Z. he named this specific integer as z. तो उसको ये पता चला कि ये जो z नाम की प्रॉपर्टी है, ये जो स्पेसिफिक इंटीजर है, वो उस मेटल की अपनी है, और फिर वो किस चीज के ऊपर डिपेंड करता है. When he tried to find it out, that he found that the question, answer for this question is that z is nothing but the atomic number of that element, which is very specific or very important property of each and every element, atom of each and every element. So he named this z as nothing but the atomic number. So atomic number is a very important or fundamental property related with an atom. So we got this one, z is atomic number. Modern sense में उसे definition define करते हैं. So atomic number is nothing but the total number of protons present in the nucleus of an atom. So that is what we get here. So all are we clear with this? So what is atomic number? Atomic number is nothing but the total number of protons present in the nucleus of an atom. हमने अभी देखा था Rutherford's atomic model के अंदर nucleus here atom has the nucleus and electrons revolve in circular orbit. और इस nucleus के अंदर जो होते हैं protons and neutrons. Protons and neutrons होते हैं. So किसी भी atom के अंदर how many number of protons are present in the nucleus, that is denoted by Z. So Z is atomic number, or atomic number denotes that how many number of protons are present in that particular atom, nucleus of an atom. That is what we can say. So this is the atomic number. So atomic number is fundamental property, and it is the number of protons present in the nucleus of an atom, denoted by Z. ये पहला हमें जो मोस्ट ने बताया, ये हम लोग आता है. फिर दूसरा जो आता है उसके अंदर, that is nothing but the atomic mass number. Atomic mass number, that is A, and scientists found that this A is nothing but the Z plus N. Z plus N ये होता है. This is the formula. बहुत इंपॉर्टेंट फॉर्मूला है, उसके ऊपर न्यूमेरिकल आता है, 2 मार्क का न्यूमेरिकल आता है, बहुत सिंपल और बहुत ही इजी न्यूमेरिकल है. A is a mass number, Z is atomic number, N is a number of neutrons. अभी हमने बताया कि प्रोटॉन्स और न्यूट्रॉन्स होते कहाँ पर है? न्यूक्लियस के अंदर होते हैं. So number of neutrons present in the nucleus of an atom is called as a neutron number. किसी भी एटम का न्यूट्रॉन नंबर क्या होता है? तो नंबर ऑफ न्यूट्रॉन्स प्रेजेंट इन द न्यूक्लियस ऑफ एन एटम. किसी भी एटम के न्यूक्लियस के अंदर जितने नंबर ऑफ न्यूट्रॉन्स होते हैं उसे हम लोग न्यूट्रॉन नंबर ऐसा कहते हैं, डिनोटेड बाय कैपिटल ए. एंड द टोटल नंबर ऑफ प्रोटॉन्स एंड टोटल नंबर ऑफ न्यूट्रॉन्स, द मास नंबर, दैट इज एटॉमिक मास नंबर ऑफ दैट atom of the element. So these are become a fundamental properties related with an atom. हमें अगर Z और N पता है, Z मतलब एटॉमिक नंबर पता है, न्यूट्रॉन नंबर पता है, तो वी कैन कैलकुलेट मास नंबर. मास नंबर पता है, Z पता है, तो वी कैन कैलकुलेट N. और इसके बारे में ये मैंने बताया था आपको कि किसी भी केमिस्ट्री के अंदर कोई भी न्यूक्लाइड इस तरीके से दिखाया जाता है, Z, A and N. These are the things. So 3 डेफिनेशन भी होता है और कैसे दिखाया जाता है. तो इसमें Z और N पता है तो A निकाल सकते हैं, A और N पता है तो Z निकाल सकते हैं, A और Z पता है तो N निकाल सकते हैं. दिस इज द फॉर्मूला. और इसके अंदर X क्या है हमारा? सिंबल ऑफ एलिमेंट. X is a symbol of element. Z is atomic number. A is mass number. N is neutron number. So ये हम लोगों को मिल जाता है. तो in that sense you can see here all these are the you can say general representation of a nuclide. And ये यहाँ पे properties आती है. What is this A? A क्या है? Atomic number. Atomic number क्या है? Total number of protons and neutrons is called as atomic number. Z क्या है? Z is atomic number. Total number of protons present in the nucleus of an atom is called as atomic number. And total number of neutrons present in an atom is called as neutron number. So there are 3 definitions, fundamental definitions, which are related with an atom. Clear? Apart from this, we have to discuss some more definitions, which is called as isotopes, isobars, isotones, and so on. Right? So we'll discuss in tomorrow's lecture. So hope so. What we have discussed in today's lecture, there is 2 atomic models. Number 1, atomic model put forth by J.J. Thomson. Number 2, atomic model put forth by Rutherford, with his experiment, observations, conclusions, and atomic model. And we have seen fundamental definitions related with an atom. Mostly discovered the atomic number, then atomic mass number, and you can say neutron number. So these are the definitions what we have seen here. So thank you very much. See you tomorrow with the next definitions and next concept. Thank you very much.